In this video, continuing the previous problem, we're going to talk about the significant figures for the answers shown to the problem. So we've got a lot of interesting stuff that we have to consider here. When we're doing the calculation, we can see that we're using a lot of multiplication and division, so we're going to be using our rules for multiplication and division with sig figs. What this means is that we need to know the number of significant figures in every value that we multiply or divide, excluding the values that are considered to be exact. So one of the first things that we're going to want to think about here is which of the values should we consider to be exact. This may be a little bit tricky in this case, because even though there were lots of guidelines that we have discussed previously for doing this one's going to throw us a couple of curveballs. First off, we know that any of the ones here will be considered exact values. So I'll go ahead and circle these. So all of these ones will be considered exact because in the cases that they are used, they are pretty much just the filler numbers. We put the 1 underneath the 2 pallets there because we wanted to make it into a fraction. So we were just using the 1 as the multiplicative identity and the division identity so that we wouldn't change the value by dividing by something different. Because of that, this is set at exactly 1 and therefore will be not disregarded when we are going into the significant determination. As for the others here, the other ones are part of conversion factors. And in general, when we have a 1 in a conversion factor, it's considered to be exact because the other value will be the measured value. Going on from here, we're going to have to see if there are any other exact values. And there are in this case, although it might be a little bit tough to see. The other exact values that we have in this case are, I'll just circle them to get going, the 2 in the 2 pallets, and our 10 from 10 bags. It might seem a little strange to think of these as exact values, but if you think about it, both pallets and bags are things that can be counted. So we can have 1 pallet, we could have 2 pallets, 3 pallets. We can't really have a different portion of a pallet as long as we're shipping an entire unit. And so that wouldn't really make sense to have a fraction of a pallet, and therefore we think of it as a counting number and therefore exact when it's shown out to the ones place like it is. The same kind of thing holds for the 10 bags that we've got here. The 10 bags, they're counting bags. The suppliers are not going to ship us half-filled bags, and so we can assume that we can have 1 bag or 2 bags, but we can't have 1.5 bags being shipped to us by our flour supplier. So because both of these are counting numbers, they will be considered to be exact. The other values here will not be considered exact. The 50 pounds, even though that is a whole number, it's not to be considered exact because it is possible that we could have 49.5 pounds of flour in a bag. This is something that is a measured value. It's something that's measured pretty much continuously, so you just keep pouring flour until you hit that 50 mark. And so this is a value that has a certain precision. The other numbers, the non-whole number values, it might be easier to see that those are non-exact. But now we know which values we need to consider in the significant figure determination. One thing that I definitely recommend when you're going through to determine the sig figures is take a look back at how these values show up originally in the problem. So if we look back at the 50, we see that it is shown as 50 with a decimal point there, so that's very important. Then look back to the others and we see 0.31, nothing else shown there, and 3.5. And I've done my best to recopy the values exactly as they appear in the calculation itself. So because of this, we'll then have to go through and count the number of significant figures in each of these values. And it actually will turn out fairly nice for us. We see that 50 has 2 significant figures. The 5 is a non-zero digit and therefore always significant. The 0 here is to the right of the 5, and we do see that the decimal point is shown. Therefore, it will count as a significant figure. The other values will be a little bit easier to figure out because they only involve non-zero digits, so 0.31 has 2 sig figs, and 3.5 also has 2 sig figs. Now that we've determined the number of sig figs in each of the values, excluding the exact values, we now return back to the rules. Our next step says we should figure out which has the fewest number of sig figs. In this case, that's not going to be all that bad because they all have the same number. So because they have the same number, the fewest number of sig figs is 2 sig figs. That means that we should write our answer out to significant figures. The answer should always match, when we're doing multiplication or division, it should match the value with the fewest significants, which we said is 2 in this case. So as you can see, as I've written this as 920 cakes. I have not shown the decimal point after the 0. What this means is that the 9 is significant, the 2 is significant, the 0 is to the right of all non-zero digits, and the decimal point is not shown, meaning it is not significant. So this answer at 920, no decimal point, is going to be our correct answer, shown with correct significant figures.